Welcome to The Explainer. Today, we're going to crack open the hood on VT Code. It's this really powerful terminal-based coding agent, and we're going to figure out what makes it tick. But more than that, we'll explore how its architecture is set up to get a whole lot smarter.
So, what is vcode really? Well, at its core, it's a super advanced tool for autonomous coding. And it's all built on this modular foundation in Rust. Now, this is important. We're not just talking about a simple wrapper that sends prompts to an AI. No way. This is a sophisticated system that juggles large language models, does deep code analysis, and executes tools securely, all from inside your terminal.
And wow, this really shows you just how much is packed in here. I mean, look at this. It's so much more than a simple LLM wrapper. We're talking about a complete system that has a deep understanding of your code, a really robust multi-layered security model, which we'll get to in a second, and this unified way to talk to over 8 different LLM providers. It even has failover built right in. That's pretty impressive.
Okay, so if we really want to get what VT Code is all about, we've got to start at the foundation. And let's be real, for an agent that can literally change your code and run shell commands, what could possibly be more important than its security model? Nothing, right?
And this right here, this multi-layered approach, is the secret sauce. It's what makes an agent like this even possible. See, it's all designed to stop bad things from happening while still letting the agent do its powerful work. I mean, every single action gets put under a microscope. First, does the tool even exist? Then, is it on the super strict allow list of only 9 safe commands? And finally, does the user, that's you, give the final okay? This is exactly how you build trust into an autonomous agent right from the very beginning.
So that brings us to the big question, doesn't it? You've got this super strong foundation. Now what? How do you build on that strength without, making it brittle? How do you give the agent more power, more autonomy, especially at scale, without wrecking the very security and efficiency that makes you trust it?
All right, so let's dive into that. We're going to look at 3 key architectural shifts that could really unlock the next level for VT Code. We'll break it down into how it remembers, how it acts, and you could say how it thinks. Okay, first on the list, the agent's memory. And the goal here isn't just to give it a bigger memory, it's to give it a smarter one.
So right now, context management is basically about token budgets and some simple compression. And look, that's important stuff. But the thing is, the agent has all this deeper intelligence that it's not really tapping into for this. It's got treesitter, which understands code structure, functions, classes, the works. And it has AskScript, which is great for finding specific code patterns. Why not use those incredible tools to manage its own memory way more effectively? The big idea is to shift from treating the context like a simple chat log to treating it like a smart, prioritized history of the code itself. Think about it. Instead of just blindly chopping off the oldest messages to save tokens, the agent could actually understand that a critical function definition from, say, 10 prompts ago is way more important to remember than a minor variable rename you just did.
And this quote just nails it. The goal is to make sure the agent isn't just counting tokens, but making the tokens count. It's all about maximizing the value of every single token you send to the LLM. Because let's face it, wasting tokens on junk context doesn't just give you worse code, it costs you real money. Making every token pull its weight is the key here, for both efficiency and accuracy.
So the path forward is actually pretty clear. Use the powerful tools VS Code already has to make its memory genuinely code-aware. For example, instead of sending a whole file back to the LLM just because you changed one little thing, it could use treesitter to pinpoint just the function that changed, and maybe its direct dependencies. Can you imagine? That would save a massive number of tokens and keep the LLM laser-focused on what actually matters.
All right, so now let's see how this smarter context can feed right into making the agent's actions safer and more flexible. It makes sense, right? A smarter agent is going to need a smarter security model to go with it.
So remember that 5-layer security model? It's definitely robust. But that static allow list with just 9 pre-approved commands, well, that could become a real bottleneck. I mean, what happens when tasks get more complicated? What if the agent needs to do something totally new and useful that just isn't on that tiny list?
And this is where things get really interesting. The idea is to evolve the security model from a simple gatekeeper, is this on the list, to more of a risk analyst. So instead of a black and white, yes or no decision, security becomes a spectrum of trust. It starts asking smarter questions. What is this command? Where did the request come from? And what's the context of the project it's working on?
And this quote here really says it all. The agent has to explain itself. This is a huge shift. For anything that seems high risk, the burden of proof is now on the agent. It can't just ask, "Can I do this?" It has to justify why it needs to run a potentially risky command, right now, in this specific situation, to get your job done.
And what this does is brilliant. It lets the agent have way more autonomy on safe, everyday tasks, like, say, reading a file in a project you've already said you trust. But it dials up the human oversight exactly where it's needed most. You get the best of both worlds, an agent that's faster and safer. And in the world of autonomous systems, that's a really rare, really powerful combination.
Okay, last but not least, let's talk about the engine itself, the LLMs. We need to think about how VT Code talks to all the different models it supports, because right now, we might be leaving some power on the table.
Now, the current setup, this unified LLM provider trait, is awesome for compatibility. It lets you switch between models, it handles failover, it's great. But here's the catch. As these models get more and more specialized, with all these cool, unique features, a one-size-fits-all approach could actually hold the agent back.
This is a classic problem in software design, right? The abstraction problem. So the proposed solution is pretty elegant. Keep a core trait for all the basic stuff, but add optional specialized subtraits for the advanced features. Things like guaranteed structured output or special reasoning controls that only certain models have.
And this quote absolutely nails the risk here. You end up standardizing to the lowest common denominator. The very thing you built for flexibility, your abstraction layer, suddenly becomes a ceiling that stops you from innovating. It blocks you from using the really game-changing features in the newest models.
So this approach creates a clear path for VT Code to keep evolving right alongside the state-of-the-art models, without needing a massive rewrite every 6 months. The agent could just check, hey, does this new model support a structured output trait? And if it does, bam, it can use it to get perfectly formatted tool calls every single time. That makes its actions so much more reliable and just crushes the error rate.
Okay, so let's pull all three of these threads together. We've got smarter memory, dynamic security, and specialized intelligence. Let's see how they combine into a single, powerful vision for the future of VT Code.
And it's really important to see that these aren't just 3 separate tweaks. They're interconnected pillars. They're designed to create this amazing positive feedback loop. See, smarter context leads to better security decisions, and more reliable, specialized outputs from the LLM improve the quality of that context and help the agent justify its actions. It's a cycle. They all work together to build a coding agent that's smarter, more autonomous, and fundamentally more trustworthy. So the question is, could these keys, smarter memory, dynamic trust, and specialized power, be the blueprint for all truly autonomous coding agents? I mean, VT Code already has this incredibly strong foundation. This evolutionary path just sets the stage for what could be the next generation of AI development tools. The core is solid. The future is all about making it more aware, more trusted, and more powerful. And really, this isn't just about building a better coding agent. This is about shaping a whole new way that we, as developers, are going to collaborate with AI to build software.